So let's move into topic 3, which is spoken about visualization, introduction to visualization and analysis of medical images. Generally, you will have much more experience on this during your ongoing studies and with various medical and clinical departments, because actually medical informatics, it's not a clinical department. But right now, I just also it's very broad topic, especially in modern time with modern techniques to perform retrieving, acquisition of medical images, and even more modern technologies for automatic analysis and processing. For this reason, I actually provide a rather basic introduction. Again, to complete, we will refer every time to our Moodle system. So let me start and share your screen. And let me move into our Moodle, get back into our Moodle system. Topic 3. Topic 3 mostly spoken about analysis, basics of analysis and processing of medical images. And such as we have many different practical solutions to do this. There is one chosen for topic 3, it's ImageJ, and yet another for topics 4, but it will be later about this. Also, to fulfill and complete this topic, you have to process second lecture. Is it second? Yes, second lecture on medical imaging. I strongly encourage you to deal with this lecture because it's absolutely necessary in case of passing quiz. And it's provide more broad information about questions related to image acquisition and processing basics. Practically, as example, we will deal only with a single solution. Right now, application called ImageJ. So here is we have two ways to use this application in browser or as downloaded application. Which one do you prefer for me to give your example? Those which could be executed in online in web browser, or that which could be downloaded and run from local computer? Please. Any point? Okay, if no question, I will, such as already available video and our Moodle spoken rather about, here is we have example how to use ImageJ with download enable application. So for you, I will provide demonstration how to use web browser application to make it working. Okay, in this case, we can run it within web browser. It's look like relatively small and simple application, but not to be mistaken. It's very powerful tool, as you can see, developer National Institute of Health, United States. So applications still in development and support, and very recently the second version 0.2 has been released. So this one a little bit outdated, but still fully useful. Especially for our basic tasks. If you will ask me what is difference between like 1.x version and 2.0, it's there on the plugins. Here is we have a relatively short list of plugins, and in modern version, it's like enlarged three times or so. So we have much more features for analysis there. But your task for today, it's only like basic introduction. Again, by link, you can download your individual task. Here is given step-by-step instruction, because application actually not native, does not have any kind of wizards or so application very demanding for users to have understanding what they want to do. And finally, speaking about main purpose of this application, it's actually rather scientific tool, that diagnostic tool. Its major aim, it has been developed by medical scientists and dedicated for perform various analysis which is related to scientific research related based on medical images. Because actually it's obviously that's daily routine usually will be fulfilled by those tools which is equipped and supplied with diagnostic equipment. So like we talk about ultrasound machine or X-rays, modern X-ray system, they are supplied with necessary software, and physician could make basic analysis. But if you are going to make some scientific work, you need something more. And here is one of these examples. Okay, here is given five task description, step-by-step instruction for all of this. So you have to complete. To complete those tasks, you also have to get access to sample images, which is on the Google Drive, accessible to your your account. As you can see, here is given different variant names. So please download corresponding variant for images. It's related to all images except task 3, because there all variants are given within single image. Okay. So let me show some example how to implement, how to use this application. And one more notice I want to add, two notices I want to add. So your primary goal will be not only modify image, but rather retrieve different, make some calculation and retrieve numerical assessment from image. So that's one of the main features of this application provide. And now, practically, when we will start, we should check and fix application basic settings. Attention, this point not available in this instruction. So first of all, before you will start with your exercise, check please color settings of your application under edit menu option colors, and validate that background should be white, not black. Background should be white and foreground should be black. So change if it's not that way. Selection could be any other color. Let's remain yellow. Okay, so if on after that, you can start with your task. So for example, let's start with exercise 1. You are given that you have to process embryo file. Let's download necessary variant from our Google Drive. According to your variant, I will use yet another file. So you can choose any location at your computer, but I recommend create separate folders for all this, and for example, create for each exercise. It's allow you to make mistake and have better organized your data. So let's load file from your computer, open. Select local files, so I will use documents. Where is my image and embryo? And so here is I have this image. The goal of exercise 1 is to calculate area and amount of these embryons, which is here on this picture. Generally, in this application, we have two analyze particle for this, which allow to do it automatically. If you want to know more about features of application, you have to read user manual, white talk book about 200 pages, but really necessary. So in this case, analyze particle have issue, it does not work with color images. Moreover, we have second issue. We don't know size of this actual sample, so we can't make any measures because we have only size in pixels, in picture units, which depend to imaging device we retrieved. So to have, first of all, to have ability to make measures, you have apply some scale. For this case, you should or must know physical size of your sample or use available information. We have scale bar there, we will use scale bar. So please switch to line selection. All this tool, it's selection tool, it's not drawing. And draw, actually select line which is close to scale bar. Few pixels mistake does not make any difference because we have size in micrometers and it's not critical. Okay, so set scale. Through analyze set scale option, you can provide a real scale. Noun distance will be 100 micrometers. And unit micrometers is required. Global would be fine. To check, it will ensure that proper scale will be applied. Now we have physical scale has been added in header of our image, as you can see. And from now, we can retrieve some reasonable measures. So first of all, to use analyze particle, next step actually to use analyze particle, you should convert this image to black and white. For this, first of all, convert it to grayscale by using image type 8-bit, and then use process binary make binary. Process binary make binary. Now we have black and white image, and now we could apply analyze particle tool. Before we will do it, we must remove artifacts. It's important because actually there is no any kind of modern artificial intelligence or more older term expert system things under this application. It's very pure tool to processing raster graphics, which just actually analyze matrix data of image. So, and a scale bar greater than embryon, it will be counted in this way, and we must prevent it. So we have to remove any artifacts which must not be processed or select region of interest. In exercise 1, we remove artifacts. So I use rectangular selection and surround scale bar with selection and use edit clear or just backspace. So clean other area. Attention, if you get black square at this step, it will indicate that your color settings was incorrect and you need adjust color settings and then restart your analysis. Most case, I recommend for you, if you made mistake, it will be most case faster to restart analysis that try to fix mistake in this application for you without proper experience. Now, last step before we move into analyze particle and select. It's critical. If you start analyze particle now, you will retrieve 0 results because analysis every time done inside selected area. So to ensure that there is no rectangular selection, I switch to line selection tool, click outside, so it will be no rectangular selection right now, and start analyze particle. Minimum size 20 micrometers, circularity left as is. I want to show outline, and I need display results, summarize, and clear previews if you want to repeat analysis few times. In offline version, you have record starts. In online, doesn't have this option, but it will work. Okay, press OK, and here is correct answer. So here is we have amount, some summary with amount of embryon in total area. You should retrieve something very similar, same count and very similar total area. And here is details about each one of this embryo. And if you use Magnify tool on screen, you will see each one has own number, so you can identify this object. Let me show you issues. In reality, this analysis have to be repeated because these 3 embryons were too close and they consider it a single one. In reality, you have get back to original image, draw lines to separate those, embryon repeat analysis. Right now, I will not asking about this, so you can proceed as is. Final point, saving results. Quickest way, it's task spoken about create PowerPoint presentation. So quick way, it's to use something like snipping tool or any other tool to get screenshot. You can copy it to clipboard and then paste into PowerPoint. But correct way with highest grade, it's to save native file because those file could be further processing. To save image, activate image and use file, save as, any format you can select, and use same folder. That's we have created. In case of results and summary, you have to use save as in that window, and there will be CSV, separate value, Excel compatible file has been used. So you can save those files, you can then later open those files again, and you will be able to continue your processing. For example, you will be able to process summary result with, for example, spreadsheet application to make some statistical analysis if it's necessary. Not in this class, but so here is why this way is the only correct. And this driving. So here is what you have to achieve in exercise 1. That will be more details on fast. I will show only, I will make only some notice about other and only maybe a few points. Exercise 2, almost exactly like 1, except you will have 1 image and you will need to analyze only 1, so you have to select that area which include leaf. You will retrieve different result. Take note of this attention. Exercise 3, all images available, all variants available as a single image. So you have to download that DNA TIFF image, place it into different folder, X3, let's say, and when you want to deal with this next exercise, you have to close all previews and then to not make any interference, and then open your next image. Okay, so here is each one is enumerated. Each one is enumerated. Attention, you have. I will not show all steps. Check tasks and follow it. Just I want to say that there is you have to apply scale there, but you have given size. You have given size which is like on screen 415. So please use data from these pictures to set scale. And when you will need make selection, let's say I will use variant 13. You have to use a segmented line. If you see some instrument contain a small red triangle, right-click, switch to another type of instrument, and we can, instead of straight line, I can draw segmented line, and double click will finalize my selection. So actually I can use measure tool, but right now it shows for me incorrect result because I have did not complete scaling step. Please do it in correct way. And finally, if you want to, let's say, to provide image like this one in your report, just no necessary create presentation. You can just submit our files to me via email. But to get a picture like this, the only way is to make screenshot. You can't save it because ImageJ does not save a selection over image, only original image. So only screenshot has to be useful. My tool like ScreenRec, or you can use Windows snipping tool. No problem, those all applicable. Or if you use another device, use tool from there, and so on. So here is the only correct way to save, like these pictures. Exercise 1, let's say. Measures required, so I shown only part of this task. Okay, also I will show for you some part of exercise 4 because it's a little bit different than other. In this case, you have to analyze this dot plot set of images to provide measures of intensivity of each sample on this case. Visually, it's clear for us where is correct result, where is best result, but we must have, in case of science, we must have some like numerical evidence. And ImageJ has some tool for this. Again, everybody will have different variants, so I will use again that 14 which fit with example, and you will have different, even sometimes easier than this one. X-Phone. Let me show this. File, open, select local file, open. So, a special tool available in ImageJ for processing images like this, electrophoretic geoanalysis. We should draw one selection, horizontal, vertical, no matter, decide to where is you will select more objects at a time. In this case, it's horizontal in my case. Sometimes vertical, different variants, and start select fast lane. I confirm it's horizontal, it's marked like 1, and I need driving anymore. I just move, click, hold, drag, I move selection, and use analyze geo next lane, and so on and so on. I will not, you must select all lanes. I will not do it because, sorry, I'm saving time. When you make selection for all your bands, you have to use geoanalysis tool and use plot lane. It will be profile of color intensiveness for each of these elements. And finally, you have to measure area inside, and this will be numerical representation of intensiveness. So actually, in this case, you have to draw, really in this case, it will be drawing some background to separate this peak from background, from this very bottom. Sometimes it touches, then no need to draw, but in my case, it's necessary. It's no need to be single line, it's no need to be very accurate, because mostly it's creation. It's just we have to ensure that our driving crossing profile. If it's not crossing, you will have error, and you will include it will be included background into your analysis, and your results will be very very incorrect. Something like this. Okay, for me it should be enough. I will not process third. Again, you must process all elements. And finally, I use tracking tool and click once inside of this closest area, which give for me absolute number of pixels inside. So it's absolute assessment area, absolute area. But for me, interesting relative assessment, not these numbers. So final steps, it's label pick on the geoanalysis, and it's give for me percentage. And here is I clearly can compare this like this pair of relatively close items. They are close, but they are different because they represent 7 and 8% of total intensiveness respectively, and so on. So how's this? So again, finally, you have to save, of course, save this dot profile, and for sure you have save results. It's for all exercise you have to do this. Okay, so this, and finally, final steps is, what do we have here? It's again a measure of intensiveness of specific red color again. So it's like we have to measure red on red. A little bit curious things. I will show some points, but again, not everything. Not everything. Let me download this image. Sorry, I use incorrect one. This one. Those may be largest and will take some seconds to download. It's fine. So open again local files and take into account only exercise 1. I demonstrate full things. Again, you have to use scale bar. I will omit this, so I will not proceed up to measures. Then just some technical steps. First of all, we have to split image into RGB channel. So image type RGB stack.